us to be able to make certain important aspects. One of the examples that were given yesterday was the example of wood that is used to make paper. The paper that Menked is actually having in his hand. Hello, hi, can you see me? The very same paper. So we use wood for that, but unfortunately, that wood needs to be cut down. When it's cut down, it means there's a certain group of animals that used to live there, and therefore they lose their habitat. Remember, habitat from grade 4 is an area where living things are found or where they live. This is just a revision on what we did yesterday. Let's move along to today. Now, yesterday we asked people to design or create a poster in which they raise awareness about the importances of caring for the environment. Ladies and gentlemen, unfortunately, I did not receive any of the posters that I had asked, but I understand some people are probably still busy with it, but this is a very nice, fun activity. Now, the first thing that we need to understand about posters is that they are creative writing tasks. What does that mean? It means that we do not have a clear answer. It's not like a memorandum where you can say 1 + 1 is 2 and the answer becomes 2. It's not like that. So they are very open-ended in terms of how they are marked. They are dependent on one's creativity. And that is why we then use a rubric to mark those. So just this is just some of the criteria that is used when we actually mark or assess posters. The first thing, the good use of color as well as different font types. That's what we do. So basically that speaks to how do you understand the color scheme? Do the colors match? Do they make sense in terms of the message that you want to put across? The second thing, does the poster have enough content related to the topic? Remember the topic yesterday was to create a poster in which is meant to raise awareness on the environment. So it means that the poster cannot be on, for an example, on a fun poster, but going out to a party. It needs to stick to the topic that is therefore designed. The third thing is the overall layout. Is it not too clustered, wherein there's too many words, there's too many pictures, to a point where it's a bit confusing. So the layout needs to be very clear and very neat. It needs to be concise, and it needs to make a bit of sense. I just want to have a look at possible answers that we might have, so, questions rather, so that I can try and respond to those on the chat box. So apologies for that. I see Toto is asking what? Toto, we were talking about the impact that we have on the environment because of the use of the raw materials. And we asked people to create a poster in which they raise awareness in that regard. So now I was just explaining that when we do posters, there is no memorandum to mark a poster. We use rubrics. So that's what we are doing. Hello, Mujad, how are you? Toto, okay, thank you so much. So Toto understands. So ladies and gentlemen, moving right along as to what it is that we are doing today. So let's go. Today, the focus or the objectives of this lesson is the solvent. What is the solvent? We will look at the solute, we'll look at mixture or mixtures, we'll look at a pure substance, and we'll look at solutions. Ladies and gentlemen, these are words that I'm sure most of us in grade 7 remember from grade 4, 5, 6, and all the way. So basically, this is the lesson objectives. By the end, you should understand what a solvent is, you should understand what a solute is, you should understand what a mixture is, as well as pure substances, and lastly, you should understand solutions. So basically, that's what I want us to have learned by the end of this lesson. So questions to think about. Excuse me, sorry about that. I want us to have a look at these, ladies and gentlemen. I want us to say, do you remember what was meant by a solute or a solvent? If you don't remember, don't despair. That's the entire purpose of this lesson. Have you seen a mixture anywhere else? When you look around you right now, or in your own, when you woke up in the morning, did you do any mixture, or did you see one rather? The third question I want us to ask is for you to give me one example of any substance that you know might be what we call a pure substance. Any example. The third question, today when you're preparing food, hello Mtogozisi and welcome. When you're preparing food today, what drink did you make in your meal that was a solution? So already, Malose, welcome again. Good to see you. So basically today when you were making food, be it the breakfast that you ate in the morning or the lunch that you probably just had or that you're going to have, did you make any solution? So those are the questions that I want us to think about. If you think about those questions, you will realize how common these words are used. I see there are some questions in the chat box. Sorry, I'm late. Hello, Maloso, welcome. We were still introducing the lesson. We are going to be talking about mixtures and solutions today. Welcome. Mama Kele, hello, how are you? Jonathan, welcome. Thank you so much for joining us. Okay, ladies and gentlemen, let us move on. So, in starting the lesson, I want us to have a look at these very important aspects or terminologies. If you like, scientific terms or scientific words. I'm using that word very selectively, and the reason for that is because when we write the exam in June, remember, ladies and gentlemen, we are still going to write an exam, and the exam is out of 60 marks. That is a lot. Now, they're going to ask us to give one word scientific terms. So usually what it is that they do, they give us a description, they give us an explanation or a definition of something, and we must then know what that one single word for that description, definition, or explanation is. So the first thing is the solvent. What is a solvent, ladies and gentlemen? A solvent is nothing else but a liquid that has got the ability to dissolve other substances. So basically, for the purposes of understanding, to simplify the content, a solvent is a liquid. And if you want to understand, you can say a solvent is water, but not all the time. But as I say, for the purposes for us to understand, we can say a solvent is a liquid that dissolves other substances. Now, what are those substances that are dissolved? That takes us to the next part of our lesson. Hello, Ope, welcome. Are you good? Wave. Hello. All right. So we speak about the solvent, and we're saying the solvent is a liquid. Now, what is a solute? A solute, ladies and gentlemen, is usually a solid. Now, this is a solid, for an example, salt that is dissolved in a solvent. So a solvent is water, for an example. A solute would be salt. Now, the salt, which is the solute, is dissolved in the water. But we keep on saying dissolve. When we say dissolve, what is it that we are saying? When we say dissolve, ladies and gentlemen, we are saying when a solute, which is solid, for an example, salt, is put inside a solvent, which is a liquid, in this instance, water, and as a result, it then is absorbed and it starts to disappear to a point where we cannot see it anymore. So let's revise what I just said. A solvent is water, a solute is salt, for the purposes of understanding and examples. Dissolving is when a solute or a solute substance is disappearing or is absorbed by a solvent. I had to bring some of these for the purposes of understanding. So this, ladies and gentlemen, would qualify as a solvent. This is water that I've put, that I brought for us so that we can understand what it is that we're talking about. So this is a solvent. Remember, in the states of matter, we've got a gas, a liquid, and what else do we have? We've got a solid. So this is the liquid, ladies and gentlemen. So this is a solvent. It is what? It is a liquid that dissolves a substance. What is the substance that is being dissolved? The substance that is being dissolved is what we call a solute. Now, this is salt that I also brought for us so that we can understand. So the salt becomes the solute. This is the solute. It is a solid in terms of the states of matter. It dissolves inside the solvent. What is the solvent? The glass of water that I have. Now, I want us to use this practically. So if you can see, there is a jar, a beaker that we have there. They are showing us the blue area, everything that is blue that I'm trying to circle with the cursor, that would be the water. Now, those yellow dots, that would be the solute, right? Now, I want us to go into actually trying to investigate how everything dissolves and how everything works. So this is the solvent, this is the solute. I'm going to pour salt into salt. Remember, salt is our solute. I'm pouring it where? Into our solvent, which is water. Then I start to stir. As I start to stir, ladies and gentlemen, the particles of the salt, which are solute or solids, if you may, if you look at the states of matter, they start to be absorbed by what? By the solvent. The solvent being the water, the solute being the salt that I've poured. And now at the end of this, we realize that the salt, which is the solute, has disappeared into the solvent, which is water. So we cannot see them anymore. What has happened? It has dissolved. So that's the point. Remember, this was a glass of water. I had salt. The glass of water is a solvent. This is a solute. We poured the salt, which is a solute, inside the solvent. What happened? We began to stir into the solvent. And when we stirred, the solute disappeared or dissolved or was absorbed by the solvent. and this is what we have at the end, and that's what we call a solution. But we'll get to that. I just want to check the chat box because I see that we might have some questions so that we can actually respond to those. All right, there we go. Okay. Hello, Tebucho, welcome. Hi, sir. When are we doing this exam? You are going to be writing the exam, Kiandra, in June. No, you're not disturbing my lesson. I actually appreciate the message. You're going to be writing the exam in June. Remember, the exam is made up of 60% term 1, 40% term 2. So we're doing the 40% for term 2. In June, you're going to be writing that exam. It's out of 60 marks. Thank you so much. That's a great question. Thank you, Ovayo, for also responding. When do school starts? We do not know yet. We'll find out from the president's address next week when the lockdown will be announced. Remember, it's 21 days. Unfortunately, I also cannot respond to that one, Viola, about going back to school. We have to wait for the president's pronouncement. Thank you so much. Is there a way for the color of water to change? That's Jonathan. Is there a way the color of water changes? No. Jonathan, remember, salt does not necessarily have a particular color, but the color that salt has, it'd be like, we can say it's white. So also water is quite clear. So it's colorless, if you may. So if we put the salt in, that's why now we cannot see any trace of the salt. And that's why we are saying it has dissolved. So that would be the answer that I'd give. Thank you very much. Let's continue, ladies and gentlemen. Those are very good questions. I will respond to them. Unfortunately, because we want to establish a certain way and a certain method of moving, we will only respond to questions that are on the chat box. Moving right along. So what are these pure substances that we spoke about or alluded to earlier? A pure substance is a substance that is made up of only one type of particle. We are going to be doing the periodic table as of next week. When we do the periodic table of elements, we start speaking about particles, and we'll go into that in more detail. But I don't want us to go there yet because then it will confuse. But basically, a pure substance is a substance that's not mixed with any other substance. It exists on its own. It's singular in how it is. For an example, salt. Salt has not been combined with anything. As you can see, this salt that we use for that experiment that we conducted earlier. So that salt is a great example of a pure substance. Oxygen also. In which the symbol for oxygen is O. Oxygen also exists. It is singular in how it is. It's a pure substance. It's not mixed. The word pure, let's remember the standard or the English definition of pure. It simply means something that is alone or something that is not touched, something that is not altered. So pure in natural sciences, for our standard of understanding, is the uniform composition of a type of substance that only has one type of particle. So it's not mixed with anything else. We go into the mixture. Now we are saying a mixture is an impure substance. Now let's pay attention to the prefix IM. So it's impure. So what does that mean? It means that impure is the opposite of pure. What does it mean? It means that, remember, pure, there's only one type of a particle that's found. Hence, example, salt, it's not mixed with anything. We've not done anything to it. Then a mixture becomes an impure substance. Hello, Bokang, welcome. Thank you for joining us. Now, we are saying it's impure because there was salt and the salt was mixed with water. Again, I go back to this experiment that we have done. Remember, there was water here. It was a pure substance. It was not mixed with anything. Then we poured salt. When we poured the salt, then this became a mixture. So what does that mean? It means that this now is a mixture of salt and water. As a result, it is an impure substance because it is a combination of two substances. Ladies and gentlemen, you can add other things. You can put sugar here. And when you stir, obviously it will dissolve. And remember, we said dissolving is when a solute is absorbed by a solvent. The solute would be the sugar that would pour here. The solvent is still the water, and we won't see. Then it would become a mixture of an impure substance of salt. Remember, we put salt here, and then we would have put sugar and water. Then, therefore, that mixture would then become a solution, which is what we would then term an impure substance because we've already mixed it with something. Welcome, Toto. Thank you so much for joining us. So I've put in a beaker there that shows us an example of salt and water that is making a solution that mixed together. If you check water and sand, I've put those pictures. And Mutueli, welcome. Thank you so much for joining us. Sonwabo, hi. Thank you so much for joining us as well. We are not too far off. We're just introducing solutes and solvent. We said that a solute is a solid such as salt. And we said a solvent is water. And we then said, when you take the salt and you put it in the water and you stir, you create a mixture, which is a solution. So a solution is a type of a mixture that combines two things wherein the solute cannot be seen anymore. So that's where we are basically. We are not too far off. Thank you so much for joining us. Now, the first picture, I'm trying to move the cursor. This picture that I'm pointing at with the cursor. So that would be a solution. This is a solution. We cannot see the salt anymore. I will get to that. But this is a mixture. If you take sand and water, you will realize that the sand particles will go to the bottom of the cup. They're going to the bottom of the cup because soil is insoluble. What does that mean? It means that soil or sand is insoluble. It does not dissolve in water. It cannot dissolve. As a result, it will go right at the bottom, as we can see in the cursor there. Moving to the next slide. So again, we go to a solution, which is what I tried to introduce in the previous slide. Prior to that, I see that we might have some questions. Let me check. Okay. Allow me to browse up a bit. Yes, Jonathan, definitely. Sugar does not change color. It remains, especially if it's put inside water. Remember, water is colorless. That's a good response. Malose. Yes, definitely. Salt, like not salt, sand will stay at the bottom of the cup because sand or soil is insoluble. What does it mean? It means it's got the inability to dissolve in water. It does not dissolve in water. As a result, it will then stand at the bottom. Absolutely. Yes. So sand and water, definitely. Sand and water is a simple type of a mixture. You are absolutely right, Kiandra. Soil and water is a mixture. Why? Because you took sand, which was separate, you took water, which was separate, you combined the two. They are a mixture. Because remember, a mixture is when you mix or you combine two or more substances, the substance being sand and the substance being water. Absolutely correct. Okay, I'm also trying to respond to the last question before we continue. Does food coloring change the color of water quicker when using hot water? Absolutely. Now that takes us back to, Mutsuli, that's a good question. It takes us back to the states of matter. Ladies and gentlemen, if you are making coffee, which is actually an example of a solution, you realize that when the liquid, which is the solvent, remember we said liquids are solvent. When the liquid is hot, the liquid is able to absorb the solute particles easier because it is hot than when it is cold. So you're absolutely correct. I'm trying to read some more questions. Yes, Jean-Pierre, what is a homogeneous mixture? That's actually where we are going. Thank you so much. Ladies and gentlemen, let's continue. I will continue reading those chat messages on the chat box and respond likewise so that we are also on the same page. Nevertheless, so a solution. So let's go back. We are saying this is a mixture, right? This is a mixture of sand and water. I'm trying to move the cursor in the beaker. It's a mixture of sand and water. However, this is a basic example of a mixture. It's basic because the sand is insoluble. The sand does not dissolve in the solvent, which is water. So this is a mixture. However, this is a solution. And maybe we need to do that again. We've actually had some salt remaining, so we need to do. So this is a solvent. That's the water, that's the liquid. This is a solute, that is the salt. We pour the salt here, right? When we pour the salt, we then stir into this cup. We've done this before, but we are doing it again. What are we doing? We are creating a homogeneous mixture. So we are creating a type of a mixture. So there are different types of mixtures. So the first one is a mixture wherein things do not necessarily dissolve or create one thing. However, this one is a mixture that is a solution that is homogeneous, right? Homogeneous means that the two or more substances that are combined together, the water and the salt that are combined, they become one substance. And that is the case. So for someone who was not listening to us, or for someone who's not part of this lesson, if they come and I say to them, what is this? They'll say to me, this is a cup of water, Mr. Songo. They will not know that in essence, this is a solution of what? Of salt, which is the solute, and water, which is the solvent, that is combined and therefore created one type of a mixture. So again, what is a solution? A solution is a homogeneous mixture. What does that mean? It means the two or more substances that have been combined, in most instances, a powder and a liquid, a powder being the salt, a liquid being the water, they become one substance. So that is the case here. So that is the solution. So the solution of water that I have here is a homogeneous mixture because it has become one thing. It's very difficult to separate, but tomorrow we will find out that actually it can be separated. All right. I asked earlier on if there's a mixture that you made when you're preparing your meal, probably breakfast. What I was alluding to was coffee. Coffee is also a great example of a solution. Why is that? Remember, you are mixing the granules or the grains of coffee and you mix them with sugar. And then when you, in some instances, I like my coffee black, quite frankly, and maybe that's why I'm so dark. But nevertheless, that's a misconception, by the way. I'm just joking, ladies and gentlemen. But when you mix your coffee, the coffee granules, and you mix them with sugar and you stir, that becomes a solution. And that solution is what we call coffee. You don't say, I am drinking sugar combined with coffee grains and also a powder milk. You don't say that. You say you are drinking what? You are drinking coffee because coffee is a solution. What is a solution? It's a homogeneous mixture of two or more substances that are mixed perfectly or completely, dissolving in the solvent, which is the liquid, the hot water, to become one thing. So that is what we are saying, ladies and gentlemen. Let's have a look at the chat box once more. Hot chocolate. Hot chocolate. Unfortunately, I cannot see the name. Thank you very much. That's also a great example of a solution. Your father, exactly, Mutswedi. So your father, unaware, this morning did a scientific experiment because he made coffee. He mixed coffee granules, sugar, and I'm assuming also what do we call coffee in that a powder milk or liquid milk. In an essence, he created a mixture. I'm trying to read some messages. All right, let me revise the homogeneous mixture. A homogeneous mixture, ladies and gentlemen, for Jean-Pierre, because he needs a bit of explanation there. Homogeneous mixture is a mixture in which two or more substances have completely combined and dissolved into the solvent to a point where we cannot see and they become one thing. So the salt, the water dissolve or combine with each other to a point wherein they become one thing. This is a solution. This solution is because it's a combination of salt as well as water, creating a homogeneous mixture to a point where it is mixed perfectly and completely. We cannot see that there was salt here. So it's homogeneous in that respect. All right, let us move on. Now, we've spoken a lot about mixtures, but in us speaking about mixtures, ladies and gentlemen, we need to speak about how do we separate these mixtures. Remember, we first need to understand that a solvent is a liquid, water, a solute is a powder. For example, salt. Dissolving is when the two have combined together. We've done this experiment twice. We put in salt here, we stirred, it dissolved. What does it mean? It means that the solvent absorbed all the solute. Jonathan, hello. It absorbed all the solute, in essence, becoming one thing, which is what we call a homogeneous mixture. However, in science, ladies and gentlemen, we do not just study these mixtures, we also study them so that we can know how do we separate them and bring them in their own distinctions. The chat box seems to be very busy. Yes, definitely. Milani, cold drink is also a solution. Well done. Zintle, I see your question. Zintle is asking if the dissolving of the solute is dependent on the temperature. The temperature becomes what we call a catalyst. It catalyzes the rate of dissolving. What does that mean? We are already jumping into grade 10, ladies and gentlemen. I'm actually very happy. It means that most of us are going to be doing physical sciences in high school. All right. So a catalyst is something that speeds up the process. You'll realize that when I put the salt here, I had to stir several times. Why? Because this water is cold. But if the water is hot, I don't have to stir that many times. So Zinta, you can conduct that experiment for yourself. So it is dependent, but the dependence is only based on the time. It makes it quicker to dissolve a solute in hot water than it is in cold water, like in this case. All right. Thank you so much, Zintle, for responding. Jonathan is asking a very interesting question. He says, can we call a baby a mixture? Last week, we were doing human reproduction, Jonathan. And I wish you were there because you would have learned that in human reproduction, we speak about the egg and the sperm cell that then combine. So remember, a mixture is when two or more substances combine to make one. So the egg and the sperm cell, the egg cell that comes from the mom, the sperm cell that comes from the father, they combine, and that definitely becomes a mixture of some sort. So Jonathan, definitely you can look at yourself as a great mixture or combination of nature. Definitely. I'm looking at Kriando's question, quite long. Yes, Kiandra, let's remember, and maybe we should go back. All right, let me apologize for that. Trying to go back. Yeah, this is the slide. So this is a solution. Both of these are mixtures. Let's first understand that, right? These are both mixtures. Why are these both mixtures? Because one substance has been mixed with another. However, these are different types of mixtures. The first one is just a basic mixture. In essence, it means that you can distinguish or you can see the two things that have been mixed. You can see the sand and the water. Why? Because the sand particles are insoluble. They are not able to combine or to be absorbed with the water. The second one is a solution that is homogeneous. So it is I can say it's a level up of mixtures. So in this level up of mixtures, you find that the solute, which is the salt, becomes one with the solvent, and as a result, it becomes one thing. So again, both of these are mixtures, ladies and gentlemen. The first one is a basic understanding of mixtures. So it's just combining two things, but the two things that are being combined, you can still distinguish. You can see them. The second one, you cannot distinguish the differences anymore. So they've combined, they've homogeneously become one thing to a point where you don't know what is what, like in this solution. So that is that, Keandra. I'm assuming that I've assisted in responding to that. All right. Shane, I will respond just now. Let me get through the slide. So we've studied what mixtures are. We've studied what solutions are. So just to recap, a solvent is a liquid or water that enables something to dissolve inside of it, right? What is that something? That something is a solute, which is usually a solid, e.g. salt that we spoke about, that dissolves inside so that it can be able to make one thing, the one thing that becomes a solution. So you can also take rocks and put them inside water. When you take the rocks and put them inside water, we are creating a mixture. But that mixture is not homogeneous. Why? Because it's not one thing. It is a combination of two things. However, you can see those two things. As a result, it just exists as a mixture. It's not homogeneous. It's homogeneous when the two things that are combined, you cannot see the difference between the two. They become one thing. I'm hoping that you understand and you hear me. All right. So there are different types of separations or methods. However, I want us to look at the skill that I want to teach you of how we separate mixtures. The first thing that we need to know is that when you separate mixtures, ladies and gentlemen, be mindful of the states of matter of the mixtures that you are separating. What is the state of matter? Is it a solid, is it a liquid, or is it a gas? That's number one. That assists you to understand the size of the particles of those substances of that mixture. And as a result, it's easier to separate them. For an example, remember we mixed salt here. We mixed the salt with water. Huawei boy, welcome. I wish I knew what your name was. It's just written Huawei boy there. Thank you so much for joining us. Nevertheless, so we mixed salt here. Salt was our solute. And remember, water is our solvent. We stirred, then the salt dissolved. It became a homogeneous mixture. It became one thing. Hello, Milani, welcome. Now, when that happened, we've got two types of sense. Remember, water is liquid in terms of the states of matter. Salt is seen as a solid. And I'm saying, when we separate mixtures, we need to be aware of the type or the states of matter so that it can be easier for us to separate them. Ladies and gentlemen, can I possibly separate this solution of water and salt using my hand? Let's think about that. Let me see if I can get some responses. I have made a solution here, a solution of salt and water. Can I separate this? Thank you so much. no. Olwethu is responding no. Entle is responding no. Zintle, no. Thank you so much, ladies and gentlemen. I love this interaction. No, say it's impossible. I like Kendra's emphasis on the fact that it's impossible, because definitely it cannot happen. Thank you so much. Mama Soke says, yes, you can. Unfortunately, you cannot. We'll establish why. Ladies and gentlemen, unfortunately, I can't put my hand in here because I still have to move through the slides, and therefore it would damage the laptop. Nevertheless, I cannot separate this because this has become a homogeneous mixture. This has become one thing. So now if I put my hand here, I cannot come out with the salt and say, this is the salt. Can you see it? It's impossible because this has become one thing. So that's why I'm saying when we separate mixtures, let us look at the type or the states of matter that they are so that we know. For an example, I am a huge fan of peanuts. However, ladies and gentlemen, I don't like raisins so much. So usually what I do is I separate the raisins from the peanuts. And what am I doing when I do that? I am using my hand. So what are we saying? We are saying there's a type of separation or a method of separation which is called hand sorting, wherein the particles are big, you can touch, you can feel them. Now you can move them with your hand flawlessly without struggle. Again, it goes back to what I said. When we are separating mixtures, ladies and gentlemen, let's look at the states of matter, which will assist us to the size. So when I separate raisins, I eat peanuts. I therefore take the peanuts and put them in my hand because that's what I want to eat. I take the raisins, I put them on the side. My son is 2 years old. He loves sweet things. So that's for him. So he will then eat the raisins. So that's me using what? Hand sorting. But hand sorting only applies in particles of a mixture that are big. So this peanuts and raisins is an example of a mixture, ladies and gentlemen. But it's a mixture that's not homogeneous because it's not one thing. You can still see the raisins from the peanuts, and as a result, it's not homogeneous. It's a mixture that we can use hand sorting to separate, unlike this one. Moving to the next slide. Sieving. What is this? So now remember the first one, we said hand sorting. So there we are separating particles of a mixture that are big or that are huge. I see we have 62 participants. I am very grateful. Thank you so much, ladies and gentlemen. This really, really means a lot to all of us at African Teen Geeks and of course DBE and Sasol SA. Thank you so much for being here. All right, so we go to sieving. So what is sieving? The word itself, in terms of how it's understood in English, actually explains itself to some extent. So sieving, you are separating a liquid from a solid, right? So you're separating a liquid from a solid. So for an example, the liquid would be water, the solid would be soil. Or you are separating two solids of different particles. So let's go back there. So sieving is when you separate or sieve out, ladies and gentlemen, the liquid from the solid. So you would have the liquid, maybe you've got rocks that are combined with water. Remember that picture that is here. So if you want to separate this mixture, I'm just moving the cursor. It will be very difficult to use your hands to separate this. We cannot do that. If you do that, it will take you forever, and that separation will not be perfect. However, ladies and gentlemen, sieving, which is number 2 on the types or methods of separation, assists us. Because what do? We take that entire mixture, we pour it onto a sieving device. The sieving device can be any cloth that has got some form of opening. What does it mean? It means that the water will pass through and only the soil will remain at the top. So what have you done? You then have water on the side, you then have soil at the top of that sieving material. As I've said, maybe it will be a t-shirt, maybe it will be a face cloth, anything. Or, ladies and gentlemen, you are sieving between two solids that are different in terms of they are because of their particle sizes. So maybe you are separating soil from stones. As you can see in the picture there, the large particles are remaining inside, the soft or the fine earth soil particles are coming out. So this person has managed to sieve what? The combination of soil, of soil and rocks. The soil is coming out because it's very small, and what is happening to the rocks? They're remaining behind because they cannot penetrate through this sieving material that is being used. So can we see that? So now the same applies. If you take water that has been combined with soil in this picture, ladies and gentlemen, I'm just moving the cursor through, still the soil will remain at the top, only the water will come out. I see that there are some questions. Let me have a look. Otaku, welcome. Thank you so much for joining us. I see we've increased to 63. Yes. Some people sieve water and rocks for clean water. Absolutely. So basically, can you see, Malos? I like this. In the rural areas in particular, in rurals, that's what they do. So they understand the science that the water is able to come out and whatever dirtiness remains at the top. Again, would not advise people to drink that water because that water might still be contaminated with bacteria. Remember, ladies and gentlemen, bacteria like the coronavirus, the COVID-19, you cannot see it through your eyes, and therefore it's very, very dangerous. So I would say I would not necessarily advise against that. But we are saying that's a very good example of sieving, but we are not saying that's what we would like to do. Absolutely. Toto, that is an absolutely great example. When we cook rice, remember, we get to a point where at first we wash the rice, then we sieve through the water, then we take the rice and put new amounts of water, then we sieve that water again, leaving the rice inside the pot. Absolutely, Toto. That's great. Someone is asking me if they want to mix water and ice cream. I don't know if that's a good idea, but you can try. But I'm assuming that then the ice cream will become very watery. And would you still want to actually drink or enjoy that ice cream? Thank you so much. Ladies and gentlemen, I truly appreciate all the interactions. Let's move on. So the third type of separation is what we call magnetism. So that example, Ndivuo, welcome. Thank you so much for joining us. So according to this, ladies and gentlemen, magnetism, in technology in term 3, you are going to do magnetism. But of course, this is not technology. We are just saying it so that you guys are more ahead as compared to other learners. And of course, you look smarter than the others, which I know that you are. All right, so what is magnetism? So magnetism is the separation of two solids in which one of the solids is magnetic. What does that mean? It means that it is able to be attracted to a magnet. So it's got elements of what? Of magnetism. So as you can see there, ladies and gentlemen, this is sand or this is soil. So we've put iron fillings. Remember, iron is made up of steel, right? If you think about the speaker of the radio, if you think about the speaker of our say our, what is this, our Bluetooth speakers. Of course, we don't want you to be breaking that speaker, but there's a magnet there. So if in that magnet, ladies and gentlemen, it does not attract each and every material that you find, it attracts only material that is made up of steel or metals, right? Now, if you can see there, iron fillings are made up of steel, right? Iron. Now, if they are combined with sand, it's very difficult for you to try and separate using your hands. So hand sorting is already out. You can't do that. It will take you forever. And obviously, it will not be a perfect separation. If you try to sieve through the iron fillings as well as the sand, the particles are almost the same. So what will remain and what will actually not remain? So again, you cannot use sieving. So what does that
Hi Alex, we still can't hear you.
All right, so I'm back now.
Okay, sure.
Thank you so much. Ladies and gentlemen, let me apologize for that disturbance. I seem to have had a bit of a network challenge there. So we're still on magnetism. I want us to revise what we did on magnetism. I see that the time is not on our side. We are saying magnetism is the separation of two solids or more in which one or two of those solids are magnetic. What does that mean? It means that they are attracted to a magnet. And I've said things that are attracted to a magnet are usually still or things that are made of iron, like iron fillings. So if you look at this Petri dish, you find that there is a sand, there's sand there, there's also iron. Now, if you use your hand to separate that, it will take forever and the separation will not be perfect. We also cannot sieve through either the sand or the solid because the particles are almost the same. So therefore, what do? We introduce a magnet wherein all the iron fillings that are attracted to the magnet come out, as you can see in the picture there. And as a result, then we've separated the iron fillings from the sand. So that's what we do. I see that we might have a question. I just want to go and have a look in our chat box. All right. Yes, I'm still here, ladies and gentlemen. Thank you so much. Let me apologize. Yeah, I'm still here. Thank you so much. I'm still here. Thank you. Thank you so much. All right, let us move. Okay, so I've got an activity that I want us to do as a form of revision. Ladies and gentlemen, again, I asked yesterday that may we please try and take a picture of this or a screenshot of this so that we can actually do these activities. Now, I think it was Boka asked me a question earlier about when we are writing exams, and I said in June. So therefore, this will be important for that because these are the type of questions that we must expect. So when we do these activities, you'll realize prior to every lesson that we will do, I will do corrections or revision of a previous activity. So that's why this is important. Ladies and gentlemen, please work with me so that we can all study and I can also assess how far it is what we're doing. So question number 1, may you please give the scientific terms for the following descriptions or explanations. So 1A says, a solid that dissolves in a solvent. What is that? Solid that dissolves in a solvent. We spoke about that earlier on, ladies and gentlemen, and we use this as an example, and we said salt is an example, but salt is not the answer. So what is the solid that dissolves in a solvent? There's a scientific term that is used. What is that? Question number 1B, describe a solution that forms one substance. Again, remember, this was our solvent. I then put in this solid, which was salt. I'm not going to give you the answer for 1A. And then we then combined these together and created a solution of salt and water, wherein we cannot see what is what. It's homogeneous because it has become one substance. So what do we call that? What is the word that describes that? So question number 2A, we are saying study the table below and decide on the type of separation that is to be used. So we've got sugar and flour, right? Do you hand sort this? Do you sieve? Or do you apply magnetism? You simply tick which one is the correct one. We've got coins and sand. Hello, Sonabo, welcome. So how do we separate coins and sand? Do we sieve them? Do we use magnetism? Or do we use hand sorting? Ladies and gentlemen, also respond to that. We've got tins and bottles. How do we separate these ones as well? Do we hand sort? Do we sieve? Or do we use magnetism? Remember, in your answers, you can respond on our social media at African Teen Geeks, that is found on Facebook as well as Twitter. You can respond by hashtagging lockdown is school. Remember, the more we respond, the more we hashtag, the more many of your classmates and friends can be able to join us. So again, let me give you a few moments to screenshot these questions, or rather to take a picture or write them down, whatever is going to work for you, so that we can be able to respond to them tomorrow when we meet again at 3 p.m. All right, let me see if we've got something on the chat box as I give you a moment to go through these questions or write them down. Jonathan is asking, in real life, when do we use magnetism? That is a great response, a question. I like that, Jonathan. Science should never become just theoretical. It should also become an everyday thing. To respond to you, maybe we do not, me and you, but I've alluded earlier on that in a lot of scrapyards or recycling hubs or buildings, they actually use that. There's a big magnet that they have, and then they would have a crane, and then that crane would then attach cars or whatever is actually attached to that. So absolutely, very good question. Thank you for that. All right. So I see most of us have taken a lot of those questions. So please, let's take them down, screenshot, or even rewatch the video again on YouTube, as well as on African Teen Geeks on social media, so that we can be able to respond. So ladies and gentlemen, what are the takeaway points from this lesson? Number one, a solute is a solid that dissolves in a solvent. So a solute is what? Is a solid, which is salt. It dissolves in what? A solvent, which is a liquid, which is what? Which is water, right? So let's repeat. This is a solute. It's a solid, it's salt. It dissolves in a solvent, which is a liquid, and that is water. What does it mean that it dissolves? When you put the salt inside the water, then you stir, the solvent absorbs the particles of what? Of the solute. It therefore does what? It dissolves. When it dissolves, it goes to my next takeaway point. It forms what we call a homogeneous mixture. What is a homogeneous mixture? Is when two things have been perfectly mixed together to a point where if I can leave this on the table and I leave it there, my little brother whom I live with might possibly just drink it because they would think that it's water, because the salt and water have become one thing. The last takeaway point, to separate mixtures, we need to look at their states of matter or their particle sizes. States of matter, again, grade 4, 5, 6 work, is solid, liquid, and gas. That assists us to know, so far we've learned about 3, hand sorting, sieving, as well as magnetism. So the size assists us to understand the type of mixture and how we will then separate it. Tomorrow, we'll learn about another 3, then we will speak about recycling. Thank you so much, Kiandra, for the good comment. I also enjoyed teaching you guys. Thank you so much. I truly appreciate those positive comments. This is awesome. I really, really am honored and humbled. Thank you so much. All right, ladies and gentlemen, these are the links that you can have a look at. As you can see, again, you can, of course, rewatch this video on YouTube or African Teen Geeks, so you can be able to see these links. Welcome, Naledi. Thank you so much for joining us. Unfortunately, our lesson is ending in a few minutes. See you tomorrow early at 3 p.m. So these are the 3 links. There are videos there. You'll also find some worksheets that will also be able to be very much useful to you. So please take a picture, or like I said, look at our lesson again tomorrow when you find it on YouTube. All right, so what is it that we are doing tomorrow? Tomorrow, we are going to explore the last part of the 3 remaining types of separation of mixtures. So that's separating mixtures part 2. So there's 3 that's left. We are going to do those tomorrow. And then we are going to look at the recycling aspect of separating mixtures. Because remember, when we recycle, we are also separating mixtures. And we're going to look at the benefits of that in terms of our environment. Remember, we spoke about the impact that our daily lives is having negatively on our earth. So we want to actually explore as to say, how do we protect that? Ladies and gentlemen, thank you so much. This is our social media platforms where you can follow us at African Teen Geeks, at Izora, at DBE_. Welcome, Deborah. Thank you so much. We are actually about to end our lesson. See you tomorrow at 3:30 at hashtag Sasol Foundation, at Sasol SA, at hashtag STEM Champions. Thank you so much, ladies and gentlemen. This was a great interaction. I will see you guys again tomorrow. Bye and enjoy the rest of your afternoon.